Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and we're going to go over how to make the strip point plot. Okay, this is a combination of a strip plot and a point plot, and I think it looks quite cool. Definitely has a unique kind of look to it. Okay, and it can be very valuable as well in our analytics, with the bonus of looking extra cool. Okay, so here just importing the standard data science or at least data analysis libraries. And then here what we're going to do is we're going to set the theme. So the background is a white grid. Okay. Here I'm importing the data just from my data set or from my GitHub reservoir, and you'd be able to do this as well if you're following along with the workbook. Here what I'm going to do is do a melt. So what this is going to create the long form and basically create a separate row. So this will be one row, and then it will be 4 rows essentially, with one thing saying petal width, and then this, one thing saying petal length, and then this. So it makes it a long form. And now these become categories to signify what this value is. So that's what melt does. And you can take a look at it if you. So we melt it, and we're going to call this new category that we create out of these 4, because we're going to have one column. We're going to call it measurements. Okay. So we have species, measurement, and then the value of these columns, right? Okay. And so, sorry, and a measurement was then where we put the categories of the type of measurement. Okay. So then we do, what I'm doing here is I'm looking at the columns. We can see we have these, and I'm going to get the index for the species. So if you do value counts, you get the count of the values, and you see the species on the left-hand side and the count of the time it appears. If you get the index, it gives you a list of the different categories that you were counting the values of. Okay. So here I'm just making a fun little having fun. Like to do different colors, get bored of the standard colors. Although Seaborn has great choices, you do get bored of them eventually. So making a palette here that we'll use a few times going down. So this I had to do to get something that did not work with their documentation. So we'll see this first strip plot. What happens is you're supposed to be able to turn off legend. Unfortunately, you're not able to turn this off. It doesn't work in this version of Seaborn. So what I did was I basically turned off the legend and made my own legend. Okay. So I don't have duplicates from 2 legends that are just duplicating basically in one legend. I want to just have one single legend, which makes sense. So I make this from matplotlib.lines and 2D line. So I'm doing a line, and I'm going to make it line width 3, and I'm going to select 1, 2, 3 for my color palette. So we'll line up when I give Seaborn palette argument my palette up above, so it all line up. Okay. So when we get into our plot, we're going to go start with an axis. We will need to get access to the axis argument or the axis object. So fig axis from plt.subplots, and we're giving it a fig size is all we're doing. So it's just creating one spot to put a graphic, but now we can control the figure size, and we have access to this axis argument, which is this square inside the backdrop where we're going to put our graph. Okay. So SNS, the standard Seaborn alias, SNS strip plot, data equals df, value x equals value, which is the number in that. Y is the measurement, and that's the column for the categories that were created from these. So this is the measurement, is the type of measurement, the category for that. This we're going to put that on the left-hand side right here, the measurements. Okay. Then we're going to do the hue species, so the colors change by the species. Dodge true, alpha equals 0.25, z order 1, axis equals ax equals ax, which is this object right here. So we're just saying to Seaborn, put this plot in that axis object. Jitter equals true, just kind of moves them around a little bit. It kind of makes it look a little bit nicer. And then palette right here. Palette equals pal, which is this palette that we created. Okay, and then sns.pointplot, same thing for these first 4, data equals df, x equals value, y equals measurement, hue equals species. Here what I'm doing is join equals false, so the line connecting the point plot doesn't exist. Dodge equals 0.8 divided minus 0.8 divided by 3. So this actually works well to create the dodge where these things are going to be a little bit separated. So this is actually an important part. Markers equals D, which just changes the kind of size. Scale equals 0.6. Error bar true, it just kind of gives a little bit more width to it. And then AX equals AX. Okay. So it's doing the strip and then the point, and then we're going to have to do the legend. So this legend is going to use the custom circles, well, custom lines, I guess you'd say, that were created before. Okay, so we create those, and then we're going to create custom circles, and we're going to put the species into the legend. Okay, that's going to give us this right here. Because if we didn't do this, let's just see. Really, you can see it has two of them. Not super, not terrible. I would just say not very nice either. So we do this right here. We'll change it so that the colors line up to this, but we only have one of each, which makes a little bit more sense. So I was just having a little bit of fun with this, and I thought this was a good lesson. So I was just playing around with another data set you might have seen, which is the penguin data set, and just looking at what we see here. So I thought this was a really good problem to discuss because what we have here, everything worked the same, but we have body mass in grams that shows a different scale, right? So these are all in millimeters and this is grams. So it's just a different scale for each one of these. So what we need to do, what we can do if we wanted to plot all of these together, we can use a machine learning from the machine learning library, sklearn.preprocessing standard scaler. So we're just going to standardize everything so it's in the same scale. Okay. So what I'm going to do, I made a list of my columns, and I'm going to go standard scaler dot fit underscore transform df cols equals to df cols. Okay, and then everything's the same. Then I do the melt species measurement. Everything fits the same. I do the value counts. I get the name of the species from the value counts index. Okay, the name of the different categories. And now that we've done that, let's make sure I do that first. And then now that we've run that cell, yeah, so I didn't run this first one. Yeah. Okay. So now that we've standardized, we can actually spot some really amazing differences. You can see here that chin strap is way over here, way to the right of the other two, and then it's way out to the left here. But then up here, you can see that Adili is way over here to the left. Sorry, I'm not an expert at penguin terminology. So this is just very interesting, the extra details we can get, but this is a great lesson in how you can plot different scales together. So thank you very much for joining me, and I will see you next time.